All right, IBAASL2. We're going back to kinematics today. Today we're going to use kinematics with integration and with a little bit of calculator mixed in there. So, if it's been a while since you've looked at kinematics, remember that S is the displacement function. V is the velocity function. Quick note that if you take an absolute value of a velocity, that is just a speed of a scalar quantity. So that might come up in some of the homework questions. And that little a stands for acceleration. Now, the hierarchy between all these things is that if you take the derivative of s of t, you get velocity. And if you take take the derivative of displacement, you get velocity. And if you take the derivative of velocity, you get acceleration. So that's moving left on this diagram, that you can take the derivative of those things to get the next thing to the right. If you want to move from right to left, you need to integrate. Meaning that if you integrate acceleration, you get velocity. And if you integrate velocity, you get displacement. This first problem we're going to start with, here's a displacement s of t function. And we're only going from 0 to 7. They gave us this sign chart in the problem. We could come up with it through algebra, but they just gave it to us. So let's talk about displacement versus total distance traveled. Now, displacement, let's read this chart first, what's happening. There's a particle moving along this straight line, moving left and right. At time 0, it starts moving to the right, and then it goes, until it gets to here. And then at time 2, it turns around and goes the other direction. So at time 2, it goes until time 5. And then from 5 to 7, it goes back to the right again. There are ways to figure out those times using algebra, like trying to find the turning points of this by taking the derivative, setting it equal to 0. But they gave us this in the function. Now, you guys, displacement. Displacement literally means the difference between where you start and stop. So it's like a stop minus start. So at time 0, we were at 3, and at time 7, we were at 80. So this is 80 minus 3, which is 77. Do we have units for this? Let me check. Meters. Yeah, these are all in meters, sorry. So meters. So 77 meters is the particle's displacement. Now, total distance traveled is a little bit different because you have to include all the distance it goes until those turning points. So from time 0 up to time 2, this is a distance of 52, which is 55 minus 3. So this is 52 going this way. Then it turns around and goes from 55 to 28, which is a distance of 27. So it goes back a distance of 27. Then from 28 to 80, it goes a distance of 52. Is that right? They're both 52? Yep, they are. So in terms of the total distance traveled, it first travels to the right 52, and then to the left 27, and then to the right 52 more, which is a total distance of 131 meters. Now, if we look at the same problem from kind of a graphing perspective, if you take the derivative of this guy right here, the velocity equation would be 6t squared minus 21t plus 60. So that velocity equation is right here. If we graph both of those, the area above the curve here would be a positive distance traveled, and this would be a negative distance traveled. Then it would be positive again. So if you were to add these three sections together, with the bottom being negative and the top, being positive, then the velocity, well, then the distance, the area of that, like if you were to integrate this thing from 0 to 7 with respect to t, it would be 77 because the tops and bottoms would cancel each other out a little bit, which is sort of what's happening up here, is that this middle part gets counted twice, so it kind of cancels out a little bit just so the displacement is just from the start to the finish. Now, the trick we're going to show you guys is that if you want to find the total distance traveled, you can integrate this from 0 to 7 with respect to t, but you need to put an absolute value sign on it. When you put the absolute value sign on it, it'll keep this part positive, but then this part that dipped below the x-axis will actually get turned up into positive area. And then this will be positive too. So this would equal 131. Because you're just adding all three positive sections together. You're pretending there's no negatives, which is what absolute values do. To put that into a formal rule, if v is the velocity function for a particle moving along a straight line, then if you integrate from time 1 to time 2, it's the same thing as taking the original equation, the antiderivative, putting in t2 and subtracting t1. That is the displacement from t1 to t2. If you're looking for total distance traveled, so not just the displacement, but the total distance traveled, you do the same thing, but you put these absolute value bars on the outside. And that will give you the total distance from t1 to t2. Our next example, a particle moves along a straight line such that the displacement s in meters from an origin O is given by that for 0 to 5, where t is time in 10 seconds. A, find the velocity of the particle at time t. Well, to find velocity, you just take the derivative of this. So that's going to be 2t minus 4. Part B, find when the particle is moving to the right and when it's moving to the left. When it switches directions is when it changes velocities from negative to positive or positive to negative, or left to right, right to left. So to figure out part B, we have to set the velocity equal to 0 and solve. So add 4, divide by 2. So at time 2 is when it switches directions. But I don't necessarily know if before 2 it's going to the right or to the left. I do know that it switches at that point. So what I will do is a quick little zone test. It's been a while. I'll pick a point like 0 and put it in there. So velocity of 0 is a negative number, which means that in this zone, it's moving to the left. And then after 2, it switches and moves to the right. Part C, draw a motion diagram for the particle. Well, we know that at time 0, it's, well, I actually don't know where it is at time 0. I just know that after time 0, it's going to move to the left, and then after 2 seconds, it's going to move to the right. But I don't necessarily know what these distances are. So in the original equation, we're going to figure out where it's at these times. So plug in 0 into S, and you get 3. Plug in 2 into S, and you get -1. Then the final part of the time interval is 5, so I want to figure out where it is at the very end. So S of 5 is equal to 8. So let's see, it starts at 3, then it goes left to -1, and then it goes right to +8. So if I draw a motion diagram, I have to go from, let's see, we'll make like 0 right here, then I have to get all the way up to 8. 1, 2, 3, 4, 5, 6, 7, 8. And I do need -1 on there. So at time 0, it starts at 3. So we'll put a big dot here on 3. And this is t equal to 0. Then it moves to the left. I know that because of this sign chart that I did. And it goes all the way to -1 and then turns around at time 2. Then it turns around and goes all the way to 8 at time 5. So it goes turn around, t is equal to 5. So that's the motion diagram. Part D, write definite integrals for the particle's displacement on the interval t, or 0 to 5, for distance traveled on 0 to 5. So we're going to find displacement. Do they want us to find total distance? Yeah, I think they do. Oh yeah, and for distance traveled. Sorry, misread it. So what we're going to do, that was part C, this is part D, is go from 0 to 5, and we're going to integrate the velocity equation to get back to displacement. This is going to be total distance, or displacement, the displacement, because it's not the absolute value one. Now, I don't even really have to integrate that because I know that it went 3 to -1, or no, excuse me. It starts at 3 and then ends at 8. So if it starts at 3 and ends at 8, this is a displacement of 5. You could use your GDC to check that. Now that was for the displacement. For the total distance traveled, we're going to go 0 to 5 and put an absolute value on the outside of that. Your absolute value lives in the catalog button. I'll show you today in class. So let's see. I'll pull them up. And then it's the very top one of your catalog, ABS parentheses. I'm not actually going to punch it into my calculator because you can tell from our sign diagram that it first goes 4, a distance of 4 this way, and then it turns around and goes a distance of 9. So I know 4 plus 9 is going to be 13. So this is total distance traveled. $13. Units on this? Yep, meters. 5 meters, 13 meters. Okay, we got one more problem here. They're giving us the velocity graph of a particle moving along a line and shown in the figure on the right. Find the particle's displacement and the distance traveled over the interval 0 to 11 seconds. This problem is interesting because there's no equations involved. We just have to take a geometric graphical perspective. So my goal is I'm going to find the area of this chunk, the area of this chunk, and then the area of this chunk. So A1 is a trapezoid that has a base of 6, and then from 3 to 5, this is another base of 2, and then it's got a height of 3. So this is 1/2 6 plus 1 times 3. Which is like, what, 21 halves? The area of the second shape is a triangle with a base of 3 and a height of 3 as well. So this is 1/2 base times height. this is 9/2. And then the area of the third triangle is a base of 2 and a height of 3. So this is 1/2 2 times 3, which is 3. So if we're going to find displacement, this part has to be negative because it's below the x-axis. So for displacement, it will be 21/2 minus 9/2 plus 3. 21 take away 9 is 12/2, which is 6, plus 3, which is 9. Am I doing that right? Oh, I screwed something up, you guys. All the way back here, that should have been a 2. So that means this should have been 12, right? 8 divided by 2 is 4, times 3 is 12. So we have to change this to a 12. So 12 take away 9/2 plus 3 is 10.5 meters. So that's the displacement, because the negative portion, like when it's moving left, cancels out some of the distance. Now, total distance traveled we're going to pretend that this triangle right here is actually above the x-axis and therefore a positive distance. So really we just have to flip the sign of this guy. So this is 12 plus 9/2 plus 3, which is 19.5. meters. Okay, you guys, that's all I got for us today. Good luck with your homework. Please come ask me calculator questions during class.